Before we move on to the other issues about the locomotion, the importance of CPG is that for the spinal cord injured patients, it is possible to train the CPG even though their spinal cord is damaged. So the methods such as body weight support system, BWS, or FES, functional electrical stimulation of the leg, can be beneficial for spinal cord injured population, and it can be applied in the rehab setting also. The next one issue is rhythmic structure of locomotion. And 1976, Craig and his colleagues found the very slow locomotion, which is less than 2.7 kilometers per hour. The arm and leg rhythmic pattern was 2:1. So if the leg have one swing, the arm swings twice. And that was found in the study. If the speed increased more than 2.7, the normal pattern, which is 1:1 arm and leg swing ratio, was found. Other rhythmic pattern can be found in pelvic and thorax rotatory motion, and they found the phase shift in increasing the velocity 0.3 to 4.3 kilometers per hour. So let's say this is pelvis and this is thorax, so it's looking from top end. So this is supposed to be head on top of the thorax. So when the velocity is slow, so it's slower than about 2.7, slower than 2.7, the pelvic and the thorax moves in phase, so it moves like this while walking slow. But when they increase the speed, the transition occurs so that it's more out of phase. So when the pelvis moves, the thorax moves in the opposite direction. When they measure the relative angle in phase in the slow motion, in phase about 25 degrees, but when they increase the velocity, it went up to 110 degrees. So those two structures have distinctive rhythmic pattern according to the speed of locomotion. And the Craig study is showing us that in different speed we have different coordinative structure. But interestingly, later these groups also did a similar study done by Craig, but they only see 3 out of 8 subjects show this 2:1 ratio, so it wasn't really universal phenomena. The other issue is head stability of locomotion. And why head stability? Because we have to use vision, and if our head is not stable, it's hard for us to accurately judge the surroundings. And also it's important for postural stability. Why is that? Because what is in our head and our inner ear, we have vestibular system which controls the balance and controls the posture in that way. So if the head is stable, we're we can accurately judge where our heads, if our heads are tilted or rotated, and from that judgment we can adjust the postural stability. So two aspects, vision and vestibular system. Because of those, head stability is important. This study showed that they actually induced the perturbation while walking. So they induced the perturbation in 3 different ways. First one, simply lift the arm, swing the arm high, at the shoulder level. That was the first one, so they were marching like the soldiers. That's one way to perturb the head stability. The second method they used was doubling the swing of the arm. So when the leg swings backwards and forwards, the arm moves twice the frequency of the leg motion. So that was second method they used. And the third method they used was they had in-phase walking pattern. So if the left arm was forward, the left leg was forward. Usually it's out of phase. If our left arm is in front, our right leg is usually in front. But this is in-phase pattern. So by doing so, they could actually increase the perturbance of the posture. But what they found was their head stability was maintained dramatically well, even though they had 3 types of different perturbation. And what they found was this stability was maintained by compensatory trunk motion. So even the body was perturbed more than normal, the trunk motion compensated that perturbation, which stabilized the head motion. The other study was looking directly to the stability of the head. And they had this measurement of looking at the coordination pattern, which defines the stability of the head. And as you can see in the picture, they put accelerometer on the top of the head, and it could identify medial lateral motion, anterior postural motion, and vertical motion of the head acceleration pattern. So medial lateral or anterior posterior is this direction, and medial lateral is left and right motion. And when they did in different settings, different speed, cadence, and length, they found vertical and AP direction, backwards and forward motion, the head stability was maximized. But the medial lateral motion, it wasn't at maximized stability, but it was just optimized stability.